Hello! In this video we are going to solve a multi-angle trig equation. The equation we're going to solve is a homework question. It says solve the equation for exact solutions over the interval from 0 to 360 degrees. Well, hopefully you recognize that this is an angle that we already know. It's one of our reference angles. So let's go ahead and show that. Usually we do not have in the past sections a double angle here. We would just say cosine of some angle is 1/2. And we know that if cosine of some angle is 1/2, what does that mean? Well, we know that cosine of some angle being 1/2, we know is cosine is adjacent over hypotenuse, or we know it's x over r. And so if we have something in the first quadrant, for instance, call this x, we know that the x is 1 and the r, which is the hypotenuse, is 2, and from the Pythagorean theorem we know that the y value is square root of 3. So theta would equal to, hopefully you recognize that angle is one of our reference angles, 60 degrees. It's not the only one though. We also know that cosine is positive in the fourth quadrant. So this was quadrant 1. What about quadrant 4? So let's draw an angle over here. Oh, it's not proportional. Oh well, but you know this is still 1 and the hypotenuse is 2, but now this is negative square root of 3. So what is that angle? That angle there? Well, we know that it's also 300 degrees. How did we get 300 degrees? Well, because this is a 60-degree reference angle in the third quadrant. The whole thing's 360. So if you take 360 and you subtract 60, you get 300 degrees. And in the past, we'd be done because it's from 0 to 360. But now we have this double angle. By the way, when you have a 2 here, that means there's twice as many answers. And you'll see why in a minute. There's a 3 here, 3 times as many answers, a 4, 4 times as many answers, and so forth. Why is that? Because if you actually take 2x, and the only answers were for that angle, we saw over here that if we replace 2x by theta here, we got the answers of 60 and 300 degrees. If you divide everything by 2, divide by 2, divide by 2, divide by 2, you would get x is equal to 30 degrees and 150 degrees. And you think that you'd be done. Go ahead and erase this. But you wouldn't be, because if you take 60 plus 360, you would get 420 degrees. So if I put a 420 degrees there and divide that by 2, what do I get? 210. Right, so again, now I do it again. Divide by 2, divide by 2, divide by 2, divide by 2, and you get the 210. You notice that 210 is less than 360. What if we did it again? Well, let's take this one, 300, and add 360 to that. What do you get? You get 660. So here you would get 660. But we're dividing everything by 2, so that would be 330. That would probably be it, because if I do the next one, 60, right, the next one would be this one plus 720. But I've divided 720 by 2 already. That is not going to be it. So what would that be? That would be 780 divided by that by 2, and you do get over 360. So we stop. Notice how there's twice as many answers. By the way, if you check this, it does work, because if you plug in 30 degrees here, cosine of 30 times 2 is 60, and we saw over here that cosine of 60 degrees is 1/2. And similarly for this one, 150 would be 300. And the reason this one works is because it is less than 360. If you multiply by 2, you get 420. 420, we know cosine 420 is on the same spot as this is. So it's an angle between 0 and 360, but it is becomes more than that once you plug it in and multiply by 2. So you have to be careful there with the double angles. So let's scroll down and look at this question. It's the same question as above, but instead of between 0 and 360 degrees, it's 0 and 2 pi. Can we do the same thing in radians? Well, we don't really need to redo this whole thing, but I will come up with another picture. Oops, wrong way, picture. Right, where we have this is square root of 3, this is 2, and this is 1. Now, we had one answer with 60 degrees up here, so now theta is going to be pi over 3, because pi over 3, if you multiply by pi over 180, that gets you pi over 3. That's what 60 degrees is in radians. And then the 300, you could do the same thing with the 300. We know it was this one down here, negative square root of 3 and 2. What is that in radians? Well, you can take 300 and multiply by pi over 180, or I can just add, this would be pi over 3. So we're breaking this pi up into thirds. If you remember, I did this before, way back in chapter 2. 2 pi over 3, 3 pi over 3, 4 pi over 3. So therefore, this right here is 5 pi over 3. We do that one in red. The angle that we want is 5 pi over 3. So we have 2x now is equal to pi over 3 and 5 pi over 3. We know there's 2 more, so we might as well do it now. If we add 2 pi, so let me scroll this down a little bit more so we have more room. If we add 2 pi plus pi over 3, what would that be? Well, we can multiply top and bottom by 3 here. Get 6 pi over 3 plus pi over 3, which is 7 pi over 3. Or you could just have logically have thought about it again. This is 6 pi over 3, so the next one is 7 pi over 3. And if I keep on going, that logic there, 8 pi over 3, right? 9 pi over 3. Ten pi over 3. And 11 pi over 3 would be the same, not the same angle, but so we won't say those are exactly the same fractions, but they are the same reference angle. So that would be 11 pi over 3. Let's see if that does make sense, because it was what? It was 5 pi over 3, so we add a 2 pi to 5 pi over 3, right? That's the other way of doing that, because I added a 2 pi to pi over 3, so I'm going to add 2 pi to that one to get that next angle. So times 3, you can see that that's where the 6 comes in, plus the 5. Which is the 11 pi over 3. So that's the 4 angles that when you divide by 2, right, so I'm going to multiply by 1/2 instead of divide by 2. Let's do that in a different color. 1/2, 1/2. So x would equal to pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6 would be the 4 answers between 0 and 2 pi. And that makes sense because we're very close to 2 pi here. What you can see are the same answers in degrees. Right, 150, if you multiply that by pi over 180, right? So this is, if they do ask you for radians and you can't deal with radians yet, you could have also just done it in degrees like I did up here and then multiplied each one of these by pi over 180. Finally, solve the same equation, but now for all solutions. So if I just looked at the radian version here, it's not saying which one to do. I can say that x is equal to pi, I want to do the original, 2x. 2x, if you remember, was 5 pi over 3, and 2x is equal to 5 pi over 3. Well, since this is now not limited to just the 0 to 2 pi, what I'm going to do is say we know that, right, we added a 2 pi to get to these. So I'm going to say a 2 pi n, where n is any integer. You could say natural number as well, but it could be negative. You can add a 2 pi n to any situation, or you can subtract a 2 pi n. So what does that mean? If I divide everything by 2 now, x would equal to pi over 6 plus pi n. Dividing, multiplying both sides, let me do it in red, 1/2. And again, multiplying both of these, 1/2. You would get, and x would equal 5 pi, and make sure you do over 6 plus pi over n. That would be the general solution. If you wanted it in degrees, if you remember what this was, then you could have just said x is equal to, that would have been, start over, right? 2x, remember, was either the original. Let's go back to the original. What was it? Either 60 or 300. So we know that 2x is 60, and 2x equals 300. So we're going to add a 360n to both. Add 360n, add 360n, and you can see, divide everything by 2, or multiply by 1/2, whatever you would rather. That is the same answer as this, 360 plus 180n, and the second answer is x equals 150 plus 180n. So if they ask for it in terms of degrees, that's what it would be there. So if you want to get all the solutions just from here, you could just keep on, like n is 1, or n is 0 gives us the 30, right? If we look back up at the original now, the general solution, there's the 30. All right, let me write those down. I'm going to copy those. So if you want a more sophisticated way of doing this, you do the general solution, and then you could just plug in n is 0, you get the 350, n is 1, you get, that's 180 plus 300, that's 210, n is 0 here, that's where you, and then you stop because it's 360, n is 0, you get the 150, n is 1, that's where you're going to get 330, and then again when n is 2, you would stop, right? And they didn't want negatives because they said from 0 to 360. So that one made sense. In a similar note, you could have done this one, the same idea. If you look at the this solution compared to this, when n is 0, you get the pi over 6. When n is 1, you get the, what do you get? You get 6 over 6, 7 pi over 6. When n is 0, you get the 5 pi over 6. When n is 1, that's where you're going to get the 11 pi over 6. So you could have just found the general, and then just started plugging in n is 0, n is 1, and whatnot until you get to your end interval. Hope this helps.